Alright, in problem number 31, we are looking to do the inverse. So the first step in the inverse when we're trying to find an inverse equation is we're going to switch the x with the y. And so to solve this, I'm going to get rid of the plus 1 by subtracting 1. And so now we have x minus 1 equals the sine of 4y. The next thing we have to do is we have to do the inverse operation on the sine, and the inverse operation on the sine is the arc sine, or the sine negative 1. And then finally we have to do something to get rid of the 4, so we can either divide by 4, where this would be your answer, or they may put it out in front as 1/4 sine negative 1 of x minus 1. And this is your inverse. Alright, for problem number 32, I showed you guys the calculator version of this. For this problem, I'm going to use the non-calculator version. And since tan is 1, I'm going to put 1 over 1, which means that this is a 45, 45, 90 triangle, or if I do the Pythagorean theorem, that's a 2. Now, since this is the triangle that we're using, I now need the cosine, which is the adjacent over the hypotenuse. So that would be 1 over the square root of 2. If I wanted to rationalize it, multiply the top and the bottom by the square root of 2. And so we get the square root of 2 over 2. Alright, so cosecant squared theta equals cotangent squared theta plus sine theta cosecant theta. And we did this problem in class changing everything to sines and cosines, so I'm going to show you an alternate way here. Because we know sine and cosecant are equal to 1, because those two are reciprocal, I'm going to have cosecant squared equals cotangent squared theta plus 1. And if you notice in our Pythagorean identities, cotangent squared plus 1 turns out to be the same thing as cosecant squared. So that's one way to do problem number 33. For this next one, I am going to do it the way we normally do it, which is to change everything into sines and cosines. And this turns out to be sine over cosine. So we need a common denominator, which is the cosine. So this part is missing a cosine. So I got 1 over cosine A minus, actually I can just do this, minus cosine squared A equals sine squared A over cosine A. I'm going to change this 1 to be the math pickup line, sine squared A plus cosine squared A, and then the rest of it stayed the same. And what happens is those two cosines are going to subtract to become 0, and I am left with sine squared A over cosine A equals sine squared A over cosine A. And so they are the same. Alright, for problem number 35, they want to know how many different ways can you pick 6 marbles from 4 pens. So I'm going to say for this one, order doesn't matter, although I'm not exactly sure. If this comes up where I'm not sure if the question is clear, I will let you know. So if order doesn't matter, I'm just going to take 6 factorial, which is how many pens there are, divided by 2 factorial, which is how many pens are not chosen. And so there are 360 ways that these 4 pens can be chosen. But that is if order mattered. But if order doesn't matter, I'm also going to divide by 4 factorial. And so if order does not matter, the answer is I can pull 15 pens. So either the pens were picked out of the box or they weren't. And so that answer is 15. In problem number 36, we have 5 remote control cars, and we have 4 friends that want to race them, and each car is different, so it does matter which friend gets which car. And we're going to divide by 1 factorial because there's one friend who gets nothing. So 5 factorial divided by 1 factorial equals 120. And here order did matter, so order yes. 37. In how many ways can 30 people be chosen for a 2 parts? You either are the lead or the understudy. Well, I want to be the lead. I guess I would be okay being the understudy because the other 28 people don't get picked. But order certainly matters. So order matters, so I'm going to put order yes. And so we got 30 factorial divided by 28 factorial to give me an answer of 807 different ways we can pick the top person and the understudy. For problem number 38, we got a group of 25 students. And there's going to be 10 who are going to a concert and 15 that are not going to a concert. So does order matter? The answer is no, because either I'm going to the concert, yay, or I'm not going to the concert, boo. So we got 25 factorial divided by 15 factorial. Gives me the answer of, because order didn't matter, I got to remember that I have to divide by 2 things. So I'm going to also divide by 10 factorial. If order doesn't matter, I divide by 2 things. So my answer here was 3, 2, 8, 6, 8, 7, 6, 0, so that was still over 3 million choices. 39, we have 8 people, and there's bronze, silver, and gold, so order matters yes, which means I'm only dividing by 1, and there are 5 people who aren't going to medal, so I got 8 factorial divided by 5 factorial, which turns out to be 336. And finally, for problem number 40, we have 14 players, and either you're in the starting lineup or you're not in the starting lineup, so no order doesn't matter. So I'm going to divide by 9 factorial and 5 factorial. Since order didn't matter again, we divide by the 2. So 14 divided by 9. And remember, if you put it in parentheses, you use a time sign down here. That answer turned out to be 2002. That's not 2062, 2002. And that is it for the review.